So I think it's a recorded session, yes. Then we can always send the recordings to those who have missed out on it. Right. So yeah, I'll just Samuel, please just share your screen or your slides or whichever one it is that you want to use. Okay, okay. My bad, sorry. Um, it's been a while. It's not my fault. Okay, Samuel, I've added you as a panelist. All right. Yeah. So if you have any questions regarding Python generally, be it you as an experienced person or you as a newbie, please do not be shy to ask. Do not hesitate to ask. Do not at any point in time be scared that, oh, this person would say it's a foolish question. There are no foolish questions. It is all about learning, learning, learning. You can ask a question over and over again. If you are still not getting something that you find very, very, how will I say it now? If it's not in line with your thought process, or if it is not simplified to a way that you can understand, you can ask again. Okay. So we are always here to assist you guys at any point in time. So thank you very much. So Samuel, yeah, you can share your screen. I'll just mute my mic now. Thank
All right. Good morning, guys. So, yeah, no slides here. We are doing a very bare and live coding session. So, I'll start sharing my screen the moment we start talking about Python, installing it, using it, and stuff like that. Please, those of you on the call, try and reach out to your friends that you know may be having issues with Python and invite them over for this session.
Okay, Samuel. Are you going to be making use of Jupyter or are you making use of Google Colab?
Oh no, I don't use I use Jupyter.
Okay, cool. Because I think some of them are having issues with understanding how to make use of Jupyter, how to import, sorry, how to zip their how to extract those files into the directory and the necessary informations that accompany it, such that it is can easily allow them to see that okay, um how to bypass some simple errors that they see, especially when they did not have those files in their directory. So thank you.
Okay, no problem. Okay, so this is 10:08. We should be kicking off in a minute or two. But I hope that everyone present here is ready to be here. If you know you have any friends that have been having issues with Python, just send them a quick message. Tell them, hey, we have someone here who's going to help us with our Python troubles. At the end of this call, everyone is going to leave this session a Pythonista. Python is one of my favorite languages. I think it's the best in the world, actually. So, so I think we're ready to get started now. So, during the course of the session, I'll be asking some questions to gauge your understanding, and then I hope that all the information I share for you will be sufficient enough to help you answer my questions. So I'll be sharing my screen now. To be sure, do we have data science learners on the call? I believe we should have data analyst learners on the call, but do we also have data science learners on the call? If you're a data science learner, just put in the chat, say up data science. If you're a data analyst, just say up data analyst. Sharp, sharp, sharp. I say one DS guy. That's very good. Okay. I think the DS are having it. We have 2 DS. We have 3 DS now. And just 1 DA. My DA guys, where you guys are? Okay, so to make this really interactive, I'm going to be sharing my entire screen. Entire screen. All right, guys. So why Python? All right, let me know if you can see my screen. You guys can see my screen, right? If you can see my screen, just send a thumbs up. Yeah, I want to be sure. I'm using Airtel. I want to know that Airtel has not fallen my hand today. All right, very good. Thank you very much, guys. So, guys, welcome to this session. Here, today's discussion is going to be all about Python. Some people already see it as a very difficult language. Well, surprisingly, it's one of the simplest and easiest language in the world. Um, I don't think any other language comes close. Yeah, other languages come close, but they're not as easy and powerful as Python. You may argue that someone may argue that there are some other powerful languages than Python, but what I'd like to let you know is that every language is as powerful in the same way. They can all do the same thing. The only difference is their syntax. And one beautiful thing about Python is that Python makes it very simple for you to get things done. It doesn't complicate stuff. So how does one really get started with Python? How does one really get started with Python? You say you want to learn Python, you want to use Python. How do you even use Python? You have to remember that Python is a programming language. It means that it's a language that you write to a computer. It's not a language you write to a human being, you write it to a computer. So everyone here, you buy a Windows PC. Most of you buy Windows PC or a Mac PC. The moment you put on that PC, turn it on, and you try to use it, what you should understand is that the interface you are using on that PC is called a graphical user interface. You push buttons, press menus, and the rest of that. What if you could write commands that the computer itself could understand, pure commands that the computer itself could understand? Now you think, let me write Python for this computer, let this computer understand Python. Well, you now need to be told that a computer is not able to understand Python unless you install Python into the brain of the computer. That's why in your first modules on the Learn platform, on the Explore AI platform, you were told that you have to download Python and install it on your system. The reason why you do that is so that whenever you type Python to your system will be able to understand that Python they are telling it. Because all systems by default don't know Python. All computers don't know Python. So you have to install Python on them. But if you're using HP, the latest HP and the latest Dell, they come pre-installed with Python. So in that case, you would think your system understands Python, but it does not. So the first thing is to download Python onto your system. And then once it's downloaded, you can start talking with it. Now, there are many ways to download Python onto your system. The advised one is to use the Python website. So you're supposed to you're supposed to search Python on Google. So I don't know Python's website offhand. There's so many things to know. So we just use Google search for simple things. So you just search Python. It brings you the first search result is the Python website. So you either go to the download section or you come to the home page. Once you come here, you're expected to download the Python application. Click on downloads. That was faster. And then you're expected to download the latest version. Once you download it, you then install it on your system. Very good. So what's the latest version? 3.14. Some of you, I think you guys, if you downloaded recently, you'll be having 3.14 too. Some will be having 3.13. Who can guess the Python version I'm currently using? You can guess the current Python version I'm currently using. Just guess. 5 seconds. What current version of Python am I currently using? Even I don't even remember. Well, it'd be nice to see if we have wizards on the call. We don't have any wizards. No one is willing to give it a try. 3.11. How did you know? Yes, that's one of the best Python versions. I use 3.11. Very good. I'll go to 3.14 very soon. But what's the difference between these versions? What's the difference? The difference is that some syntax changes. So there's some things you can do in 3.11 that if you want to do it in 3.14, which is the current version now, they would have removed like one character and then they made it more easier. You get. So let's say in 3.11, if you were writing like 6 characters to do something, on 3.14, they might say, oh no, you don't have to write those 6 characters anymore. Just write 2 characters and you have the same thing. You understand? So the syntax just changes, syntax differences. Thank you very much. Syntax differences. That's just the thing. And also performance differences too. Yeah, because they also change some underlying codes and stuff that make everything works. So, but then this is one way to have Python. The other way is to use Anaconda that you guys installed. How many of you have installed Anaconda on your system? You installed Anaconda on your system. You have. If you install Anaconda on your system, you are now using what is known as a proxy. Like you're now using somebody else to help you do Python. Like if you install Python on your system, then you're doing everything by yourself. But then if you install Anaconda, you are saying, I want this application to help me manage everything about my Python. I don't want to manage it myself because managing things yourself can lead to some errors if you don't know what you're doing. So that's why Anaconda was created, to help you manage things by pressing buttons and clicking menus. That's the job of Anaconda. So if you have it installed on your system, very good. You now make use of it. So you either install Anaconda or you install Python. So once you've installed the Anaconda, one very good benefit of the Anaconda is that it helps you have different versions of Python on your system. So look at this Python website right now. This is 3.11, 3. You know that as it is right now, I have only 3.11. If I was to download 3.12 onto my system, there is no way 2 of them will coexist and I'll be able to use them independently. You know, on Windows, you can only have one version of one app. So if I install Python, I'll have 3.11, I'll have 3.12 on my system, but my Windows will not be able to help me move from this version to this version. It will always prefer one version over another. But Anaconda now makes it easy so that you can have plenty Python versions. Anaconda says, don't worry, I won't be like your Windows that doesn't let you choose which version you want to use. Me, I will have all the versions inside of me, and you can decide to use which one you want to use. So that's just the key benefit of Anaconda. Helps you manage your Python versions. So those Python versions are what are known as Python environments. So now, the first thing after installing Python is you want to confirm if you have Python on your system. Yes. So most of you, the best way to confirm is you either open an Anaconda prompt. So if you search Anaconda on your system, that's after installing Anaconda, you see something called Anaconda prompt. That is if you went the Anaconda way. You see something called Anaconda prompt. So you're supposed to open the Anaconda prompt. And inside of here, you're supposed to write the word Python. Then you now say dash dash version. This is just a quick tip. When you write this, your system, the Anaconda prompt or your terminal will tell you what version of Python you're currently using. So this is me using 3.11. For you, maybe when you installed the Anaconda, what came with it was 3.13, 13.3 or 13.4, then that is what you will see. But this is a quick way for you to know what version of Python you're using. Once you've known what Python version or what version of Python you're using, the next thing is to ask yourself, how do I now start writing Python? What is Python? How do I start coding Python? Well, Python is a very high-level language that is very similar to natural language, meaning very similar to English. It is used for, see, beautiful thing about Python is it's used for everything. Anything you can think of, Python is used for. Web development, AI, data cleaning, data analysis, so many things. Rocket science, physics, every applications of man, data science has a role to play in it. I said data science, Python has a role to play in it. Don't mind me there. Data science is in my head. Python has a role to play in it. Python is everywhere. Python is that language that can do everything. It's called a Swiss Army knife. It's a general high-level language. Some languages are best for some things over another. But you see Python, yeah, it's also best for some things over other. But the fact that it can do everything is an attribute of the language. All right, so let's get started with Python. We are going to be using Jupyter Notebook. Now, you guys, all of you installed Anaconda, and then if you check your list of apps, some of you will see, let's say you go to J, some of you will see Jupyter Lab or Jupyter Notebook amongst your list of apps here like this. You will see it. Some of you would not see it, and that's fine. So, but if you don't see it, whether you see it or you don't see it, what you need to understand is that the Jupyter Lab that you were told to use to start writing Python is not an application that is installed on your system. It's an application that is installed inside the Python on your system. So you know you installed Python or Anaconda. Inside that Python that is inside the Anaconda or the Python that is on your system is an application called Jupyter Lab, and that's the application you're going to use So most of you will see here, most of you will not see it here. So well, whether you see or you don't see it, how do you open Jupyter Lab so you can get started with it immediately? How do you open Jupyter Lab so you can get started with it immediately? To open it, you need to just open your terminal. So this terminal, yes, this is a terminal, this black place. Most people like this place. They can do anything in this place. Yes, you can actually write Python in this place. The rule of writing Python in your terminal, or this is called a shell. Most people call it a shell, some call it a terminal. Some call it CLI, command line interface. So you can actually write Python here, but the rule is that if you want to write Python in your terminal, you have to say Python first. You just type only Python. Once you type it, Python now comes alive on your terminal, and you can start writing Python here. I can do print 2 plus 2. But you see, nobody likes this because this environment is black and boring. There are no colors. If you make an error, everywhere will just be red. Let me try making an error. Print 2 plus 2. Okay, it's not even red, luckily. But this shell environment, it's bland. It's not interactive also. That's why Jupyter Lab, VS Code, Jupyter Notebook, that's why they were created. So that you don't have to resort to an environment like this. So if I wanted to leave this, I'll just say exit. All right, exit with 2 braces. And then I'm out. But if I want to stay inside of here and make sure I write Python here and let the system see the Python code I'm writing, I'll stay in the terminal, but nobody wants to do that. So when we open our terminal, the best thing we're supposed to do is just type Jupyter Lab. Jupyter Lab or Jupyter Notebook. Now, who knows the difference between Jupyter Lab and Jupyter Notebook? I wish you could give every one of them their mics so just speak. Well, you guys are going to have to type. Who knows the difference between Jupyter Lab and Jupyter Notebook? Those of you are using Android, if you want to type, you can just turn on voice typing. And you just type with your voice if you're using Android. I don't know about iPhone users. No shades to iPhone users. But Jupyter Lab, Jupyter Notebook, who knows the difference? Who knows the difference? All right, very good, very good, very good. Someone says his research has not gotten there. All right, so me, I prefer using Jupyter Lab, and I'll show you why. When I was still in the ALS program, we were taught to use Jupyter Notebook. I was using it, and I noticed a problem with Jupyter Notebook, and that problem forced me to find out about Jupyter Lab, and I realized that Jupyter Lab was a lot better. So let's open Jupyter Lab. So I'll open Jupyter Lab and I'll open Jupyter Notebook and we'll show you their difference. So how do you open it? Just type Jupyter Lab on your terminal and just press enter. When you do this, something runs on your terminal. It's called a server, a Python server. So you should not close that thing. You should leave it to just, once you run this command, try not to close the terminal. Don't press this X button like I'm about to do here. Don't do that. Just minimize it and forget about it. So as long as that black thing is running, you'll be able to write Python codes on your environment. Okay, so my Jupyter Lab is opening. Then let me also spin up Jupyter Notebook, and then you will see the difference. Jupyter Notebook. But if you look at the name already tells you what you need to know. Something says it's a lab. Something says it's a lab. Have you been to a lab? You guys, secondary school now, you guys had labs. A lab is a place that has so many tools. It has all the tools and all the equipment you will ever need for your job. If you're a chemist, your lab has everything. If you're a physicist, your lab has everything. But look at the notebook. A chemist notebook, does it have everything? It can't have everything. If a physicist notebook can't have everything, so he goes to the lab because he wants everything. Yeah, but no shades to notebook. Just to let you know that a notebook is limited to just one notebook. The lab has plenty of notebooks, allowing you work effectively and efficiently. All right, so this is my notebook. This is my lab. This is my lab. This is my notebook. What do you say about my lab? The lab has a file manager interface on the left and a workspace on the right. A file manager interface on the left and a workspace on the right. But look at your notebook. Notebook only shows you one thing at a time. It doesn't see multiple things, just one thing. So me, I usually do all my work in a OneDrive folder so that in case anything happens, I know it's always backed up to the cloud. And then I have a desktop folder here. And then what's left is to create a project, a folder for today's work. Because every work you do, please, every work you do, guys, make sure it's arranged in folders so that you don't have to be looking for it. Right now, if you ask me to look for a particular thing I did some weeks ago, I don't have to track it by the date or the month. I use the folder names to just find everything. So today we are doing introduction to Python. So I'm going to use my Jupyter notebook to create a new folder. I'm going to say new folder. And then I'm just going to say, what do we call it? Introduction to Python. And I say ALX, boom. I didn't spell introduction. Okay, spell well, very good. And I go inside of it. Now look at it. I'm going inside this folder. Let's now go inside this folder using Jupyter Lab and you see the difference. So in Jupyter Lab, I say, I refresh, I'll do this so it comes up. I can press this thing so that the latest one comes up. Is a trick. I just press introduction to Python. And then see, I am inside this folder and I still have my workspace on the right looking at me. So whatever work I'm doing right here stays here while I play around on the left. But in a notebook, you don't see any other thing unless what you're playing around with. So let's create a new notebook in Jupyter Notebook. So don't confuse the difference. This is lab. This is notebook. So on notebook, I'm just going to say new Python 3 notebook. Then it gets no name. It gets no name, and then it opens in a new tab. It opens in a new tab. Nobody wants that. I know some of you, your tabs on your Chrome is messy. You have over 100 tabs. If you're using Jupyter Lab, right, those tabs are going to contribute to all the tabs you have on your messy Chrome management, on your tab management on Chrome. But if you're using Lab, where's Lab? See Lab. Right now, I just did two things on Jupyter Lab, and I have two tabs. So the more things you do, the more tabs you have on your browser. Not cool. Nobody likes to have a so much tab like that on their browser. Let's say I mistakenly open a new notebook now. I'm going to have an extra tab on my browser, right? But look what happens on Jupyter Lab. On Jupyter Lab, let me refresh. On Jupyter Lab, you just click on this and it doesn't affect your browser at all. It just opens inside this lab space. So if you want this, use Jupyter Lab. It opens, everything opens inside the lab space. So let's get started with Python. So to continue with this, I'm going to be closing the Jupyter notebook. I don't want to make use of it. What else? What else? What else? Let me now, so because I don't want to use notebook, see this notebook thing here, right? I'm now going to close it because I don't want it running on my system when I'm not using it. So this one is for lab, this one is for notebook, so I'm just going to close this. Now, if you were getting an error, when you try to open Jupyter Lab, it's simple. It just means that what's the word? Don't use your normal terminal. If you have an Anaconda, make sure you use an Anaconda prompt that you're using, right? And when you get inside the Anaconda prompt, if you're getting an error that something, just run this command: pip install. See my spelling. I say I don't go school. Jupyter Lab. Yeah, pip install Jupyter Lab. Yeah, someone's hand is raised up.
Sorry, hi Samuel. I think you are a little bit too fast. Please kindly just reduce your pace a bit. And sorry, whoever is call me bounce, please be more formal. Some of the words you just used are not friendly. Thank you very much. Thank you, Samuel. Let's go.
All right, thank you. Sorry for being too fast. Crazy. All right, I'm going to slow down. So let's go. Also, yeah, where was I? Pip install Jupyter Lab. If you want to install Jupyter Lab, if you want to make sure you don't have any errors on your environment when you want to open Jupyter Lab, make sure you just run pip install Jupyter Lab. When you do this, it forces the Jupyter Lab application to be installed on your system. Once this command runs successfully, and you just type Jupyter Lab like we did in our previous, if you just did like this, Jupyter Lab, then Jupyter Lab is going to open for you. All right, so what I was saying is that Jupyter Notebook causes cluster of different tabs on your browser. Jupyter Notebook causes cluster of different tabs on your browser. If you're using Lab, those clusters will not be on your browser anymore. The clusters will be inside of this environment. So if I opened a new notebook here, the clusters will always be inside my my lab environment here. So if I have like 5 more notebooks, see, everything just going to cluster inside of this environment and doesn't affect my my browser's experience at all. Yeah. All right, so we're going to use lab and we're going to get started. So everybody, if what we're doing now is I open the folder called Introduction to Python /ALX, and I'm going to rename it. So this notebook has been created. What's left to give it a name? So let's call it Python 101. We're going to call it Python 101. All right, so if you're also getting an error that says Python not installed, then it means that you don't have Python installed on your system. Manual, like you didn't install Python in your system, but rather you installed Anaconda. So the Python is inside the Anaconda. So the only way you can get access to the Python is when you go through Anaconda, which means that you must open the Anaconda prompts or Anaconda shell. So on your system, search Anaconda, you see an application that says Anaconda prompt or Anaconda shell. It means it is from there you'll be able to talk to the Python that Anaconda has installed for you. Yes. So the reason why mine is working is because there's no Anaconda here. This is Python that I installed myself. So I can talk to the Python directly by myself. Can we access JupyterLab through Anaconda? Yes, yes, yes. You can access it. But if you're having any troubles with JupyterLab now, right? Just for the purpose of moving forward, just use Jupyter Notebook. Yes, use Jupyter Notebook. But this command I told you that if you open Anaconda and JupyterLab is not working, that same Anaconda prompt, tell it pip install Jupyter Lab like this. And if that thing was giving you Anaconda issue, meaning it was not in your Anaconda, after you run this command, it will now install this thing on your Anaconda. And then that Anaconda that was giving you an issue about not opening JupyterLab, it will now open JupyterLab. Yeah. So this is the command you run if there's no JupyterLab on your Anaconda. Yeah. Once you've run this command and then you call JupyterLab in the future after this, like this, JupyterLab will start to work because now you installed it yourself. So that's the thing with Anaconda. There's some things it gives you and there's some things it doesn't give you. But it should, nonetheless, you should find a way to be able to tell it what you want, write in the command and everything else. So this is Python 101. We're getting started. We want to get started now. So, guys, the very simple and first command in Python everyone should know is the print statement. You guys have used it over and over. It's a print statement. So let me just look into the meeting, grab somebody's name and print it. All right, so let's print Chigozie. Yeah. When I run this, the result Chigozie comes out. Chigozie, what type of data type is Chigozie? What type of data type is Chigozie? Chigozie is a string. Yes, so we have 4 basic data types in Python. We have 4 basic data types, 4 basic. We have strings, we have floats, we have integers. Who's the last one? Give me the last one. Last basic data type we have. The last one that I haven't mentioned. Someone give me the last one. Strings, floats, integer. One is missing. Thank you very much. Boolean. Who's that? Victoria. So most people call it bool, most people call it Boolean. Yeah. So these are the 4 basic data types that we have in Python. Now, if you're wondering how I wrote this, it's a markdown cell. It's not a code cell. This is the beauty of interactive Python notebooks. It lets you write stuff so that people can read. Makes your notebook interactive. So I wanted to write these things. They are not Python codes. These are English words, normal statement. So I tell the cell, I click on the cell, come here and I say markdown. Then it becomes a markdown. So markdown is another word for text with formula. So if I do like this, a text. Because of this dash here, it means that this text should be a numbered or a enumerated something. You get of this dash. If I put 1 dot, it becomes number 1. You get. So this is just a formula. So markdown is just a text written with formula. Yeah. So you can write so many formulas to get different styles. That's what markdown is for. But forget about markdowns for now. I'll be using it sometimes, but focus on the code. So Chigozie is a string. Why did you call it a string? I need someone to tell me why it's called a string. Most people, most learners, most new people coming to Python for the first time, they always forget why something is a string, why something is called a string. Very good, because of the double quotes. If there are no double quotes, it's not a string. That's it. Very simple. So always remember that. So let's go. These are the 4 basic data types in Python: strings, floats, integers, boolean. So if I say someone's age is 16, and then their gender is that they are a male. If I print the type of age, what should this give me? If I print the type of age, what should this give me? Age is 16, gender is male. What should this give me? It should give me integer, because the values inside of age is a number. And I'm printing the type of age. So it's going to give me 16. So if there's anyone here who doesn't understand how we got this result, please let me know. Now someone is being proactive and telling us that if we do the type of gender, it would give us, string. So let's find out if the person is correct. Very true. Printing type of gender gives us string. So this very nice, simple thing about Python is why people love Python. Straight to the point, it doesn't give you headache unless you allow it to give you headache. All right. So basic data types, very easy. So you guys also know about the input function. In Python, when you want to take input from the user, we always use the input function. So to make things better, we're going to spice it up with an input function. I'm going to do like this: name right here, because I say name equals to, this makes name to be a variable. Name is now a variable. So what's a variable, guys? A variable is just a container. A variable is just a container. Just like how your bag is a container that's holding something. So you're going to the Akka space, you put your laptop inside your bag. That your bag is a variable. And then the stuff inside the bags are the values of those variables. So a variable can hold anything. It's just a container to help you hold something. In this case, if my name is Samuel, anytime you print name, you're going to see Samuel. Just like how your laptop is in your bag, if someone steals your bag, they have your laptop. That's just how it is. So let's go. But then in variables are in data science and data analysis, variables are mostly used to work with data. Variables are mostly used to work with data. So there are 4 basic data structures that we actually use. Just for a start, these are basic data structures. See these ones here, right? Most people also call them data structures, but we'll just say data types. These are primitive. These guys are, let's call them primitive. They're primitive data types. It means they are the ones that they control everything under the surface. These guys, yeah, let's just use that term for them. Because yeah, they're like the foundational guys. But then let's now move to the big guys. Let's call them basic data structures. That's what they are. So I'm going to make it a markdown. And then you guys should be mentioning for me. We have list. What's the next one we have? What's the next one we have? After list, what do we have? Tuple. Yes, somebody has given us tuple. Next one. Dictionary, guys. You guys need to be reading your dictionary. Yeah. These guys are answering this thing now. Nobody told them in their dream. Nobody told them in their sleep. You read it. That's very good. So if you want to be like these guys, put in the work. Good. List, tuple, dictionaries, and sets. Very wonderful. These are the main 3. Now, how do you know a list? How do you know a list? It's very simple. It is denoted by, let me change the word denote. It is denoted by this symbol. That's it. It is denoted by this symbol. You see these 2 symbols. That's what's denoted by it. And then when it comes to a tuple is denoted by round braces. Yeah. See this symbol. This one is for list. This one is for tuple. Somebody is giving me answers. Please, let's write down the name of this person. If we are sharing something, we share for them. Yeah, they're doing really well. Thank you very much for the expo. The set is denoted by this. Now, this is where most beginners get it confusing. Both of them are denoted by the same structure, a dictionary and a set. So let me do it like this. Guys, do I need to zoom? Do I need to zoom in? Can you see my screen and what I'm typing? Let me know. Do I need to make my screen bigger or it's fine like this? All right, thank you very much. So now, when you talk about lists, it gets denoted by this. When you talk about tuple, it gets denoted by this. When you talk about dictionary and a set, they are denoted by the same thing. The only difference is that what contains is denoted by this symbol, but it contains key and value pairs. Thank you. Thank you very much. Denoted by this, but has no key and value pairs. Only just values. So that's the difference between them. Dictionary is denoted by the same symbol as a set, but it's just that it has key and values inside of it. Like one key, one value, another key, another value, another key, another value, another key, another value. While a set, nah, no key and value. Everything is just values. So let's create our first sample list. Let's call this list 1. Now I'm going to need names of 3 people. Victoria's name is going to stick out. Her name is in chat. You can see it. If you want me to write your name, just put something in the chat. Hey, call me Bounce. Let's just add Bounce. Sharp. Bounce. Jim. Yeah. All right. So these are the 3 guys we have in our list right here. List 1. Then I want to create tuple 1. Tuple 1. Tuple 1. You see my list. Look at my list. You see that what does the list contain? The list contains 3 strings. And most people, when they're writing the list, they forget that each string is different from the first string. Yeah, each string has to be independent so that they are on their own. So if I do it like this, it's no longer 3 strings. If you look at it, it is 1 string that contains 3 people's name. It's not fair. That's not how you store data. That's not how you put information. So Victoria is different from bounce. So you have to put Victoria as a string of its own. Bounce also has to be a string of its own. The same for Jim. Like that's how you do it. So for your tuple, you also do the same thing. So let me get 3 other people's name from here. Samson. Yeah, I'm going to use Samson. I'm going to use Chigozie, even though I've used the name before. Chigozie. Next one I'm going to use is Ola. Yeah, I see an Ola. Very good. So now in this tuple and the list, we have 3 people's names. Let's now go to dictionary. But if you notice, look at the names I'm giving to these variables. List 1, tuple 1. Why am I doing that? Why am I not just calling it list? It's very simple mistakes that learners make. Why am I not calling it list or tuple? Why am I saying list 1? Well, it's because if I use the word list, you see the word list, what's the color? I want someone to tell me. I'm not the only one. I want to know I'm not the only one saying this color. Because it's not like my eyes is the only one that is sharp here, but you guys' eyes have to be sharp too. Are you seeing this list? What's the color it has? It's a keyword. But what color does it have? It's green. When you see something colored green, it's a warning from your IDE to you telling that, hey, this thing you're writing is the name of somebody, it's the name of something. All right, someone's hand is up. We can wait for you. If you have something to say, you can type it. So I'll wait for you if you want to type a question. But it's colored green. It's an indication from the IDE telling you that this thing is a keyword. This thing is the name of a particular function. It's the name of something. So use it the way it's supposed to be used. So I'll show you how it's supposed to be used as we proceed. Right now, when you're doing stuff and it's colored green, be careful about those kind of things. So here, dict is colored green. It means that if I don't want to mess anything up, I don't have to call my variable dict. It's going to spoil it. So I will just call it dict1. But I think it should be called dictionary1. Yeah. Dictionary1. So inside dictionary1, we were told that it's denoted by this symbol and it has key and value pairs. So what are the keys we're going to have here? So here I'm going to say name. Name is a key. And now I'll talk about dictionaries once I finish creating this value. And what's the value for this person's name? I need a name that we haven't called before. Cynthia came in clutch. Cynthia, where have you been all this while? I didn't say your name. Thank you for giving me a name. So Dictionary name is Cynthia. Now, if you look at it, what is this key here? This key is a name. How do we know this is a key and this is a value? How do we know? Someone should tell me. Looking at this, how would you know that this is a key and this is a value? How would you even know that this is a dictionary? There's something inside here that lets you know it's a dictionary. Bounce, God bless you. Wow. Let's do something. Let's put Bounce's name here. Shout out to Bounce. Yeah. Shout out to Bounce. Yeah, so when we share this notebook with everyone, everyone is going to say that we're giving a shout out to Bounce. Correct. Shout Bounce got something here. Because of this colon, that's how you know it's a dictionary. If there was no colon there and it was a comma, then you know it's a set. But if there's a colon there, you immediately know it's a dictionary. That's it. So I'm not putting on that comma. What else do we do for Cynthia? What else do we give her? Let's give her a gender. Yeah. Gender. So you have to be careful when you're constructing the key and the value so you don't make mistakes. So take your time, go as slow as you want to. So gender here, I'm going to give her female because I assume she's a female. If I was in America, they would say they'll sue me for assuming that somebody was, a female. So, but I hope I can assume that you're a female, Cynthia. We're in Nigeria, right? So I should be free. All right. I assume that you're a female. Thank you very much. Now let's go to sets. You see set is also colored green. It means I have to be careful the way I use that word. So I'm going to say set one is equals to a dictionary. And then inside here, there's something about sets. So I'm going to create all of this and I'm going to tell you what makes each of them different. So in a set, I can have anything. I could say, now I need names again. I need names again. All right, guys, give me names. I see Bob. I see Daniel. I just need two more names. I've written Ola before. I see Akame. That guy has been calling me to write his name since I've not written it. Sorry, bro. Oh, Akame, that could be your surname. All right. And then let's see. Let me get new names. Yes, Daisy. That's a really nice name. So which one? Alexis. Okay. Say actually is Alexis. Alexis, are you Nigerian? All right. So Bob, Daniel, Akame, and Alexis. Very good. Very nice names. Now, look at these four things we just wrote. They are very different. Because of the kind of, oh, Daniel, nice to meet you. Because of the kind of symbols that we use to enclose them, it gives each of them very different attributes. Very different attributes. See this list one, because of this thing that we use right here, it has made Victoria, Bounce, and Jane to be very distinct from Samson, Chigozie, and Ola. It has also made Samson, that bracket to put around Samson, Chigozie, and Ola, has also made it very different from this dictionary right here. So in Python, everything you do, the system sees it and the system does accordingly. It sees that your list one has this thing. So it will treat your list one differently than how it treats your list two. So what is it about list one? List one is just a list. Now let me also put here in my data structures that these, why are they called data structures? These are objects that hold collection of values. That's all. Guys, if you ever want to hold a collection of stuff, data structures are the way. I mean, for a start, like if I want to collect 5 people's names, I want to hold it, I'll store it in a list. Instead of saying name one is equals to, look at me needing new names. I start forming now. I start hallucinating like an AI. Instead of saying name two is equals to David, you see how I'm storing people's names in different variables. It's a hassle. So a list says, no, you don't have to do that. Just store them inside of me. I'll hold it for you. So now, when you store something in a list, when you store something in a list, it means it is mutable and ordered. That's what it means. That's the real reason why you store something inside a list, because you want it to be mutable and ordered. But what's the meaning of mutable? Someone should give us the meaning of mutable so everyone reads it on the chart. Yeah, it's because you want it to be mutable and ordered. That's why. But then when you store something in a tuple, when you store something in a, oh, sorry, all right, I'm back. When you store something in a tuple, it's because you want it to be immutable and ordered. So it should still have order, but then in this case, it should be immutable. That's why. That's the only reason why. So in Python, you have to know the reasons why you're doing stuff. And these are the plain, simple reasons. So all those big grammars you were saying, they shouldn't make you think they're hard. They're very simple. Tuple is because you want it to be mutable and ordered. You want to be able to change it, but at the same time, you should preserve that order. Right? A tuple should preserve the order, but it should not be able to change. I mean, whatever you've put inside it should remain like that. While a dictionary, very simple. Sorry, I have so many browser shortcuts on my keyboard, on my browser, so I accidentally pressed some of those shortcuts by accident. So dictionary, why? A dictionary, well, is mutable, ordered, and allows to store data in pairs of key and value. That's just why. Because you see these two, list and tuple, they are wonderful. They allow you to store things, but they don't allow you to store two information in one place. Take a look at this. Look at Victoria, right? I've stored Victoria. What if I want to store something else about Victoria inside the same place? I can't, because if I say Victoria, Bounce, Jim, what if the next thing I want to store about these three people are their names and their age and their gender? How will I do it without messing with the integrity or understandability and readability of this list? So if I go inside here and I say 14, 17, 18, like this list makes no sense anymore, because for anyone to understand what's going inside this list, you have to call me and ask me, what does 14 mean? What does 17 mean? What does 18 mean? It makes no sense. That's why a dictionary was not created, to say, okay, let's make sense of this data so that everything inside here can be given a name. That's it. So a dictionary is mutable, it is ordered. What you put there will arrange itself the way it is. But then the reason why it's now of a higher degree is that allows you to store data in pairs of key and value. That's all. So when you see things for the basic things that they really are, you start to appreciate them. Like if a dictionary does not exist, how would I store this kind of information? So that's it. Then what about sets? Sets, the last guy. Sets. Well, sets. Yeah. Is it mutable? Yes. I would say semi-mutable, because when you can't really just let's look at our set then to figure out if it's mutable. We have set one, right? See this set one. Everybody, you say set one, right? Can you see it? What was the first name I gave to set one? So I'm going to write something about sets. The set is unordered. He doesn't care about how you order it. What's the first name I gave to set one? I gave Bob to set one, but I went to go and put Akami first. So it was Bob, Daniel. Let me copy what I wrote here so we can see it clearly, so that we know that the set is whining us. See, look at the set I created. It was Bob. But then when I checked the set, Bob came here. I put Daniel next, but look at where Daniel went to. I put Akami here, but Akami now came to the first side. I put Alexis here, and Alexis now came to the second side. This to let you know that set is unordered and doesn't allow for duplicates. That's just it. That's just it. That's just it. So they notice that there's a problem with all the, sorry, it has to be markdown cell. They notice that there's a problem with all the other methods, all the other guys, list, tuple, all of them are working fine, but none of them ever tackled the problem of duplicity. Is that the English word? I think that's an English word. None of them ever tackled the problem of duplicity. If it does not exist, let's create it today. Right? None of them tackled it. So set is the one that tackles it. That's why it was created. It says, do you want unorderedness? I'll give it to you. At the same time, I'll help you tackle duplicate values. So let me now go inside this our set one and redefine it. Let me create Akami 2 times. Akami. See Akami, yeah, I'm going to create it twice. So set one, Akami. Now let's run this cell again. Now most people, they forget that the cell before is not the same as the current cell. Now, like this cell, this result is the old result. So I have to run this again to see the new result. You get? So I'm going to run this again. When I run it, you see that Akami appears only once. But when I was creating the set, I put 2 Akamis. Well, a set says, no problem, I can help you fix your slope. If you make a mistake and add duplicates, just know where I'll help you remove all of them. So that's the power of a set. Now, a set is unordered, allows for duplicates. And one last thing, it's not really mentioned in some textbooks, so let me just put it here. Unordered doesn't allow for duplicates and enables mathematical sets like operations. So if you ever want to do something, you know how sets works in mathematics? Yeah, right? Yeah, if you ever want to simulate that mathematical set operations, well, Python says we have a data type, a data structure called set that will allow you to do everything you can mathematically do with a set on mathematics. You can do it here on Python, and I will show you. But then, as set gives you these privileges, it allows you to do all of this, right? It doesn't let you do something like this. Sorry, set one. It doesn't let you do something like this. That's why I had to mention that it's unordered. It's unordered. This unordered, it's not just about how it's showing you which one comes first, which one comes last. The fact that it's unordered also means that you can't ask it for who the first person is because there's no order. You see this Akame, right? You guys are seeing, right? Now that we are looking at Akame, Akame is here. The moment we take our eyes off the sets, Akame is running around inside the set. Alexis is running around inside the set. Bob and Daniel are running around inside the set. Nobody is staying in one place. So when we try to ask our set, who is in the first place? Set does not answer us. It says, you can't ask me for people inside me. The kind of order here, it does not exist in this world. That's what the unordered means in this case. Even though when you ask a set to show its full self, it shows you something, and it even shows you in alphabetical order. I know some of you must have noticed it. See, all the A is here, all the B is here, all the D is here. Well, this is just the set, just doing over Sabi, showing you in alphabetical order. Let's create a new set, set 2. Set 2 is equals to, if I do 2, 47, 94, minus 1, right? Yeah, and then when you're writing your Python code, always have space for readability. If not, you go to Python prison. Set 2, this is it. 2, 47, 57 minus 1. And then let me print set 2. Set 2. Guys, tell me, which one do you think will come first? Let's see if we get it. Which one do you think will come first? Which one do you think will come first? Minus 1. Somebody has cracked the code. Set as for your hand. That's it. This guy is unpredictable. He can do anything he likes. Nobody will decide for him. It's unordered. Don't forget. Duh. So that's it, guys. Be careful when working with sets. At least if there was a duplicate, it helps us remove it. Let's do minus 1. Yeah. So you see how the set bamboozled you guys. See how it wind you. Like it gave you alphabetical order here. Like that's how it will do every time. Okay, do it again now. Let's see. Duh, Baba could not do it again. So don't let it fall for you. It's very unordered. Anyways, if there were duplicates, it helps you do with duplicates. That's why people like it. Now, that's the beautiful thing about them. So let's look at a list. We have our list 1. Look at list 1. If you put in list 1, if I ask list 1 for the first person inside it there, what will I get? Who tell me what this will be? This is not the first person, this is just index 1. What would this give me? Bounce. Somebody just give me bounce. That's correct. Because Python is 0 indexed. So let me put a very big something here so everyone can see it. Everybody see, if you forget this, to bite you in the ass a lot of times. Python is 0 indexed. So as it's biting you, you'll be learning small. Python is 0 indexed. So you may forget this, so just always remember when it happens again. Python is 0 indexed. Everything starts from 0. So if you say 0, it always starts with the first one. Yeah. And then you see this thing, this green thing I was telling you about, right? It's very simple. What does it do? This is called a list function. Yeah, this is called a list function. This is called a list function. This is called a list function, or a list constructor. And the people English, the English that they use and confuse people. So in case you go online, head list constructor. This is the same thing. It means is this guy will help you construct the list. So see what happens if I give my tuple 1. Everybody see this tuple 1. I give this an argument to the list function. Now, what's the function? A function is everything you do that has a bracket in front of it, like your print. So you guys have been doing print since. Yeah, that's a function. Now, we call this an inbuilt function. What is an inbuilt function? Because it's not you that created it. It was created by itself. I'm sorry. Come on, let me close the door and do some kind of noise. I hope Zoom has noise filter in the mic stuff. All right, inbuilt function. Yeah, a function that you did not create, that you met here when you came to Python. Like it's not you and your brother that put the print function here. Somebody did, the Python team. That's why it's called the inbuilt function. So, and you've been using it all this while. Print boy, and something was coming out. Print girl, and something was coming out. Well, the list It's just like that. So when I do this, it's going to convert this tuple one. I like what this guy said. Follow com function. Let's put it right there too. Follow com, although you need to spell your com well. Follow com function. This is not, not paging I'm speaking here. Follow com function. Yes, you see it. Follow com. This is P. Let's put it like this. Anyone that sees this will know. Please, it's PG, no. Follow com functions are, yeah. And the list is part of them. The list is part of them. And the list is part of them. All right. So if I run this, the list is designed to take anything and convert it to a list. Now, before I run this, look at tuple one. What's in tuple one? What's in tuple one? Tuple one is a tuple. Are you guys sure? If you want to be sure, don't use your eyes to be sure. Use a type function to be sure. Please, always use the type function. This has made people miss some subtle differences. Type. If I check the type of tuple one, it says it's a tuple. But when I put that tuple one inside this list function and I run it, what comes out, guys? What do you see? A list. Yeah, the same thing with this tuple guy. Anything you give to the tuple, it will convert. So let's say list one. You know that we have something called list one earlier. If you want to see what the list one looks like, I can do it right here. I can show you list one. Look at list one. It's a list. But then when I carry that list one and give to a tuple, right, it's going to change to a tuple. So all these functions they do this kind of things. All these functions do this kind of things. You get. So these are the things with Python data structures. Dictionary, we have another one called dict. Well, this one is not like everybody else. You don't just give it a list one. Let's see what happens if I say, like this dict is also a dict function. It takes things and converts it to a dictionary. Yeah, that's what the dict does. But if I give it list one, will it convert to dictionary? It can't. It can't. Because it converts to dictionary, it doesn't mean it just converts like that. Look at list. List is able to convert tuple one to a list because it's compatible. Like if I ask you to turn water to wine, you can do it if you know science. Yeah. Turn wine to water. You can do it if you know science. Can you turn firewood back to wood? Can you turn charcoal back to wood? Some things are reversible, some things are irreversible. So the logic of this is that there's some things that you can't just convert to another just because you can. A list cannot just become a dictionary like that. It doesn't work like that. So this dict guy is not used to convert a list and a tuple to dictionary. It's to convert something that is compatible. Something that is compatible. That's what it helps you convert. So what are those things that are compatible? Whatever the things that are compatible is if you write stuff like Samuel, let's see this. Let's say Samuel, I may be wrong, but I think this is it. Samuel, sorry, name is equals to Samuel. Let's try this. And then lastly, age is equals to 2. Do you see what I wrote there? You see it. This is what the dict expects you to do. It says, give me what I can convert to something that makes sense for me. And then when I write something like this, I don't have to put that dictionary logo. I don't have to put colon, colon. So that's what the dict is used for. So just because you saw how list is used to convert to one list, supposed to convert list, a dict is not just say, you can't just come here and say dict and list one because a dictionary has key and value. But the only thing you have inside your list one are values. You need to give it the keys so it makes sense of it. So this is how you make sense of everything. So just like this now, I have created the dictionary without confusing myself about the strings and the colon symbol. Do you see it? So that's it. Let's now move on to functions. Let's now move on to functions. I know there's a lot to unpack, but if you have questions, type in questions. If you have questions, let's see. Someone dropped something in Q&A. Okay, let's go. What else can we do? Functions. Oh, before we even go to functions, we need to do loops real quick. Wow, my internet connection is unstable. Can you guys still hear me? Can you guys still hear me? Okay, you guys can still hear me. And then someone put in a question and said list out. Oh no. List converts anything you give to it to become a list. I say Victoria. Tuple converts anything you give to it to become a tuple. Yes, that's it. So let me know if you understand. If you don't understand, I'll go over it again. And I'll do it with a real practice. Let me just separate this. No more, I like to separate things. And see, if I say create a list of these guys, see this set. I have 1, 2, 3, 4. If you notice, this thing is a set. You see it right there, right? I put it inside the list. Once I run this, that set will be converted to a list. That's how straightforward it is. If I do tuple, right, like this, and inside this tuple, I put a set to 1, 2, 3, 4. See, it's converted to a tuple. Now, this thing only makes sense if you store them in a variable. So I'm going to call, so I always have to make sure I store it in a variable so I can only use it anytime I want to. I can call this my tuple. So when I say tuple of this, then it becomes my tuple. When I say list of this set, so this set becomes a list immediately. This set becomes a tuple immediately. So any quick question before we go to loops? Someone's hand is raised. All right, no questions. Now let's now go to loops. What are loops? What are loops? What are loops? Very beautiful thing. Loops. Loops. Loops, yeah, loops. If you understand 2 plus 2, then you will know 2 plus 2 plus 3. Do you understand? The secret is just know how 2 plus 2 works first. Once you know how 2 plus 2 works, then 2 plus 2 plus 2 plus 2 plus 2 means nothing to you. That's just it. So loops, what are loops? It's very simple. Loops just they repeat things. They repeat things. They iterate things. Loops repeat things, they iterate things. So there are two types of loops. The first one you guys were taught is for loop. First one you guys were taught is for loop. That's the first one we taught. So we have for loop and we have while loop. We have for and while. These bad guys. One of them is very dangerous. Yeah. For loop. Now, what's the rule for using a for loop? What's the for loop? My rule is that if you want to repeat things multiple times, you want to repeat things multiple times, and you know how many times you want to repeat yourself, that's a for loop right there. Yes. If you want to repeat things multiple times and you know how many times you want to repeat yourself, that's a for loop. So let's put it right there so nobody forgets it. You want to repeat yourself. Now, when I mean yourself, I mean an operation that you're doing, right? Because it's you that is doing it. So it's you that is typing. You want to repeat yourself multiple times. Sorry, don't mind my typing. And you know how many times you want to do it. That's a for loop right there. You want to repeat yourself multiple times and you know how many times you want to do it. So now, to do this, you need to know some rules about for loop. Oh, and so Bounce don't give me another, Bounce has given me another word. You want to repeat yourself multiple times, so you know how many times you want to do it, or you want to iterate. People that go to school, you want to iterate. Iterate is to run over 1, 2, 3. That's what it means to iterate. To iterate means to just go like this, to move. That's it. And if you see, as the person is moving like this, he's repeating himself. What it does here is what he does here. He's doing the same thing. That's what iterate means. So you want to repeat yourself. So to use a for loop, and the reason why you're doing that iteration or repeating yourself is because you know how many times you want to do that thing. So use a for loop, and the rule of a for loop is that you always start with a for keyword. So I'm going to write these rules as comments here. Put the for keyword. Once you put the for keyword, add the name for value. This thing serves as a placeholder. Add a name Add the name for the iterated value placeholder. Guys, so what I'll do, I'll say for name in, no, let me not say name. Let's say for people in. Guys, this thing is called placeholder. That I call it placeholder because that's what it is. Because you can call it anything in your when we were taught teaching you guys, I told you that you should use for I in, for X in. I like to use descriptive names so I don't get lost in my code. For people in, now let's find a list of people who want to iterate over. Let's create new set of names. Let's call them our people. Now, we need fresh names for our people. Please give me names in the chat. These people will be regarded as our people. Allah has already said something. Give me names. Just say something in the chat. Even if it's I, you can say, I just need your name. Should we have bars? Ukaba. So if I'm using your surname, you take it like that. This is your surname is going places. Sarah. Samson, you are doing a Juro voice. It's good. You're helping us out. We need one last name. Asintoka. Asintoka. That's a really nice name. Asintoka. I feel like taking that Ashesh. Sorry, I'm pronouncing it. Let me just keep quiet. Yeah. Ola, Ukaba, Sarah, Samson. Yeah. These are our people, guys. Our nice people. So for people in our people. Now, if you see what I've written here, these are how many things? This is number 1, this is number 2, this is number 3, this is number 4, and the most people always forget this is number 5, the colon. So let's write it. Before keyword, the name for the iterated value, the in keyword, in, you need it, don't forget, the in keyword, and lastly, the iterable. The iterable, let's say the collection, the iterable, that is, see my typing. The collection of things you want to iterate. That thing should have a, thank you for giving me the correct spelling. That thing should have it should be a collection of things that you want to iterate. And then lastly, no worry, it should begin to make sense how to run it. The colon symbol. Once you follow these rules, you won't make any mistake. And lastly, the action you want to carry out for each iteration should be indented under the loop, under the header. Yeah, let's call it. Guys, where's the loop header? This is the header of the loop. This is the person that started the loop. Now, whatever it is you want to do, you indent it here. Let's say I want to print Samuel. Guys, for people in our people. Now, let's not even call them people. Let's say for name in our people. You see how I change from people to name? It means it's up to me. I control it. I can write anything I want to. So for name in our people, print Samuel. Now, let me ask you, how many names do we have in our people? Someone give me an answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 names. If you know the correct answer, just write it. I know I was counting wrong to see if people will follow me. I got that. 1, 2, 3, 4, 5, 6, 7. All right, so we have 7 names. If you say it's 7 names, then Samuel should be printed 7 times. But Chigozie has told us that it's 5 names. So when I run this, how many times do you see Samuel printed out? 5 times. This is the thing I want to repeat myself for. This is the action I want to carry out. So I'm carrying out this action for all the names of people inside our people. Because there are 5 people there, I want to do 5 things. If there were 6 people there, I'll do 6 things. But anything I write here will happen based on the number of times people are inside there. So in a for loop, let me also write this here. Let me write something dedicated to a for loop. For loop. For loop. Sorry, let's put it. A for loop needs an iterable. Guys, this is it. It needs an iterable. What's an iterable? An iterable is something that has a collection of things inside of it. That's an iterable right there. An iterable is something that has a collection of things inside it. So in the for loop, it needs an iterable. Now there are 2 types of iterable. In fact, there are many types of iterable. Oh, let me slow down. So guys, what is something that has a list of things inside it? Look at our people. Look at our people. Does it have many things inside it? Yes. It has separate, singular, separate things inside it. That's an iterable. Okay, someone's hand is raised. Ukaba, tell me what's not clear. Is it what a for loop does or what an iterable is? All right, let's go again.
Samson, your hands are raised. Sorry, your hands is raised. Please ask your question.
Oh, ask a question. Now, someone said Samuel is not the name of those people. Well, this is Python. You can do anything you want to do. And in my own case, I wanted to print Samuel 5 times. But then if I actually wanted those people's names, right? If I wanted their name, this is what I would do. I would not say print Samuel. I would say print name. Remember, what did I say a for loop was? I said you want to repeat yourself multiple times, and you know how many times you want to do it, right? And then I said something. I said the action you want to carry out for each iteration should be indented. The action you want to carry out here is custom. Let's call this the action. Let's call this the action. It's custom. It's up to you. But because I said print name, it is those people's name that will be printed. Do you see it? Ola, Yukaba, Sarah, Samson, Asitoke. Do you see it? Well, then I can change it. That's why Python is, that's why programming language is beautiful. You can do anything you want to as long as you're allowed to. So if I say, don't give me those names, print Samuel. Because I have 5 names, to print Samuel 5 times. But if I change my mind, I can say, give me those names, and it gives me the names. So your mic will not show, so you have to type your question. So let's give you 5 seconds to type your question. And then 5 seconds for everyone to think about what we've done. So for name in our people, print Samuel. You can use the Q and A button. And then if you're an Android user, you can use voice chat to quickly type if it works while you're in a meeting. All right, so one thing about lab is that you see how this space is now small. If I press this logo here, this logo right here, to close the file manager, and I can have an expanded space for me to work with. Beautiful. So hold on. All right.
So, hi Samuel.
Yes.
Please, can we recap again? I think some people are having issues understanding the for loop concept. Please, can we take it again?
All right. Okay, guys. A for loop takes a for loop needs an iterable and then a placeholder for every value inside that iterable. Remember this, a for loop needs an iterable first, and then a placeholder for every value inside that iterable. Now, it needs a command, an action, a statement, a code for what you actually want to do for everything inside that iterable. So because there are 5 names inside our people, this means that I can do something 5 times. That's what it means. Remember this, because there are 5 names inside our people, I can do something 5 times. Now, do you know what this person decided to do here? This person decided to print a string. Let's write it. Sorry. He decided to print a string Samuel instead. Now, I know that Samuel is not part of people in our people, but then because I know that a for loop allow me does things 5 times, like allows me do something based on number of something inside something. So for every name, what's the first name? First name is Ola, right? Instead of printing Ola, I told the for loop to print Samuel. Then again, instead of printing the next person's name, which is Ukaba, he went ahead and printed Samuel again. Samuel is a string. Samuel is a string. Samuel is nobody. It's just a string that I put there to let you know that I can repeat actions multiple times based on the number of things inside people. This means that I have printed Samuel 5 times. Do you know that if I wanted to print Samuel 5 times, I have to repeat myself 5 times? Watch. Do you know that I have to do this 5 times just to get the results that this guy gave me? Take a look at it. Do you see how it printed Samuel 5 times? But I have to write the print every time. Well, I'm lazy, so I made a for loop do it for me 5 times using the names of those people inside our people. So, but then to actually make it make sense, you are now shown that if you don't want to do an action, you want to do something else, like to print the names of those people, then this is if then you just print the name instead. So this is what you were expecting, that I should print the name. But I want you to open your mind to the possibility that a for loop is not limited to the placeholder. A for loop just says, what is that thing you want to do based on how many number of people or how many number of things are inside here. And then see this placeholder here. Why the for loop is doing things multiple times? That placeholder allows you to get access to those people that are inside the table. Okay, it's going to make more sense when I do this. For I in range of 5, print I. Someone tell me what this will give us. For I in range 5, print I. For I in range 5, print I. Now, if you don't know what is happening here, let's bring that our former guy. See this guy, let's bring him from before and look at this guy. You'll see that they are exactly the same thing. Sorry. Let me clean this comment. Guys, what do you see? You see our people. Are you correct? What do you think range 5 is? I told you that our people here must be an iterable. Range 5 is also an iterable. It has the numbers from 0 to 4 inside of it. Just like how our people has the names of our people inside it. Now, the names of our people, we called it name. But me, I'm saying that the people inside this range 5, I'm calling them high. But actually, I should call them numbers, not high. High is arbitrary, high is somehow. So I'm going to say number, but you people are used to high, but you can do anything so that it helps you understand. Change something that makes sense for you. So for number in range 5, print number. When I run this, I get 0, 1, 2, 3, 4, 5. But you know that instead of printing number, I could say print yay, and it prints yay for me. That's it. So but let's use I because we are familiar with I. For I in range 5, print I, and it's giving me those I. So that's a for loop for you guys. That's a for loop for you guys. But one thing about the for loop is it needs an iterable. So most people, the iterable they always use is a list, a tuple, something else, or a range. Now, see this range. I know you guys can see our people. You can see what's inside our people. There's a list of names, but you can't see what's inside the range. So you are confused. Well, let me show you what's inside the range. A range is a function that generates a list of numbers from something to something. That's what a range is. A range is a number generator. A range is a number generator. Now, if I ask range, what do you have inside you? Range is going to say, I have zero numbers from 0 to 5. But guess what? The range will not show you those numbers. It just want you to believe that those numbers are there. So if you actually want to see it, there's a trick. We always use the list function on the range and then to now vomit all those numbers for us. So these are the numbers you see inside your range, 0 to 4. Yes, these are the numbers you see inside your range. If I say 10, you'll see 0 to 9. But the thing is, the range will not give you these numbers because it's hiding them for when you want to use them. So that means the range is an iterable, just like how our people is an iterable. And guess what? What is an iterable? An iterable is just a collection of values. That's all. An iterable is just a collection of values. That's it. Big name for something small. A collection of values. Your dictionary, an iterable. Your list, an iterable. Your tuple, an iterable. Your set, an iterable. Mention anything again. Although, guys, is this a collection of values? Is this a collection of values? Look at it. Is it a collection of values? Yes or no? Is this a collection of values? No, it's not. It will only be a collection of values if they are all separated by comma, because mathematically this is just one number. So it's not a collection of different numbers. It will only be a collection of different numbers. If there's 1, 2, 3, 3, 7, then it becomes a collection of values. You see right there. So this guy is an iterable. This guy is not. So I can't use this guy in a for loop. It won't work. So when you have an iterable, you can use it in your for loop. But most people are lazy, so they use range for their iterable because that's the best when you want to do things 5 times. Instead of using it for names in our people that has 5 names, you just say for I in range, you get your things 5 times. So if you notice this for loop, it does something 5 times. This one too also does something 5 times. So use anyone that you like. They all both do something 5 times. But that's just the rule to an iterable. So let's now move to a while loop before we cover functions. Let's move to a while loop. Let's move to a while loop. While loop. Then we'll do functions. While loop is carry out an operation for as long as a condition remains true. Guys, don't mind my typing. I did not learn to type. I went to go and learn to code. Carry out an operation for as long as a condition remains true. Carry out an operation for as long as a condition remains true. This repeatedly carries out an operation as long as the condition remains true. Bounce. Your name is Bounce, right? For as long as your name remains Bounce, this class will not end. Do you know that because of that statement right there, the moment as long as your name remains Bounce, if you not change your name, this class will not end. You must change your name for this class to end. Do you understand? If your name remains Bounce, this class should not end. That's a while loop. But the moment your name changes from Bounce to Bouncer, class will end. That's a while loop, guys. That's a while loop. That's a while loop. So how do you do it? You just put the while and you say name is equals to Bounce. Oh, sorry. Let's do it. So I'm going to set, there are rules you have to follow. So everything in programming has rules. So let's look at the rules of this guy. I showed you the rules of the for loop, right? See the rules of the for loop. I showed it. Where is it? Yeah, I put it here. I said you must obey this command. You must put your for loop. You must put the for keyword. You must add the name for the placeholder. You must put the ink. It's too long. So, but you have to just be doing it and understanding it and let it be part of you. Why for a while? These are just the rules. Have a stop object first. You know that I said as long as his name is Bounce, this thing should what's the word? This thing should, the class will not end. So if I come here and say have a stop object, it's very important. Most people forget. Use the while keyword, add your condition. Don't forget. Sorry, I guys will learn this typing. Now get in school. Don't forget your colon. Yeah. And then lastly, indent the action to be carried out. This will make sense once you see the code. All right, guys, I'm going to disobey this first rule. You see this first rule? I'm going to disobey it and see if it works. I'm going to say while person underscore name is equals to bounce. Print this class is still ongoing. This is what I want to do. Normally in the real world, you write the things you actually want to do, the things that help you fulfill the objective. In our own case, our own is simple. We're just saying this class is still ongoing. This class is still ongoing. Now, why person name is equals to bounce, print this class is equals to is still ongoing. When I run this, I'm going to get an error. Do you know why? because it doesn't know what person name is. It doesn't know who person name is. You say, guy, you're telling me that when this person's name is, as long as this person's name is bounce, the class should be ongoing. But who is this person? That's why you must have a stop condition, a stop object first. So in my case, I say, okay, this is the thing that will start it, and this is also the thing that will stop it. So I need to have it. If I don't have it, this thing will not even start in the first place. So I'll say, okay, person name is equals to bounce. Now, guys, you see that person's name right now is bounce. And then this is a conditional check. What are conditional checks? Let's show you what conditional checks are. When you use double equals to, conditional, yeah, I said add a condition, right? That's a condition. When I use equals to, or I use greater than or equals to, or I use less than or equals to, or I use greater than, or I use less than, or I use not equals to, those are conditions. These are what are known as conditions. These are what is known as condition. So when you want to do something, you use these guys for your conditions. Let's test one of them. Let's say a, guys, what do you think this one will give us? True or false? Will this give us true or false? Let me print it so it makes more sense to you guys. Print. This will be true because A is equals to A. So it's giving us true. Do you see it? True. It means that this condition you are putting here, this condition you are putting here must return something like true or false, because it says this repeatedly carries out an operation for as long as the condition remains true. So this condition must always be true. The moment it is always true, it will be this. Now, let me ask you, is this thing not true? If you use a church mind and you run this thing, it's not going to be true. Let's look at it. You see, where is it? Okay, I've not run person name. Let me create it first. So I'm going to create it and I'm going to delete him so you don't get confused. Now, if I run this, person name is equals to bounce. You see what it's saying? It's saying, it's true. This person name is equals to bounce. If I say not equals to, this is not equals to symbol. It's going to say false, so it is equals to it. So you saying not equals to it is a false implication from your hand. So here I'm going to say person name equals to bounce. So this means that this person name is actually bounce. So this is just to show you how comparisons work. And then if I say person name is equals to bounce, I've set it here, and I say while person name is equals to bounce, do this. Guys, this is going to create what is known as an infinite loop. And somebody gave us a hint. The person was warning us, thank you. God bless that person. I wouldn't have known. Like, I don't know. You would have run this thing and it should just hang my system. This meeting will just close. To crash the meeting, said, and then the internet all over the world will crash. So person name is equals to bounce. Like, that's a joke. Infinite loop. When person name is equals to bounce, print this class is still ongoing. And let me ask you, did we at any point in time change person name from bounce to Samuel? Looking at this code, is there any piece of code that changes our person name from bounce to Samuel? Nope. Person name never changed. Because of that, this condition remained to be always true. And because of that, this thing will keep printing from now to tomorrow because person name is still bounce. Now, if I run this, I have to be quick. I have to be quick if I don't want my system to crash. Quick to stop my Python. I have to be very quick to stop my Python. So let me do, I'm going to run this, and then I'm going to press the stop button here. I'm pressing it multiple times to stop my Python. So I'm very quick, I pressed it. But then look at the result. See, it's already very long. And computer is fast. You can't wind computer. Computer is fast. See how many times the printed class is still ongoing. Do you see it? And then I have to use the keyboard interrupt option by pressing this thing to stop the program. It means that the while loop had only just one job. Look at the job I gave to the while loop. The one job is print this class rows is still ongoing. So the while loop did something. It printed it for the first time. Once it printed it, the while loop now start again because it's a loop, it repeats. Now start again and do it again. It start again, do it again, it start again. Only that thing I tell it to do, which is this class is still ongoing. But before it does that thing, it will always check, is this person's name still true? I should not stop it. Like, you buy a new laptop for me. Person name is, because the person name is always bounce. Because the person name is always bounce, it was still doing that action I tell it to. So this is what I would do. I will not do like this. So if I run it, my system, my RAM, see this RAM has a fail safe. Where is it? I say my RAM. This terminal, this guy here, this guy that controls everything has a fail safe. It will realize that you are doing something dangerous. So him for itself will stop whatever it is you are doing to stop you. Him that. So the system will crash first. Then to not say, I hope you install something that would have killed your system. At least it crashed it, but not killed it. So, but I don't want it to crash. So I'm not going to stop it. So whenever you want now, so warning, here's a note of warning, here's a note of warning. I'll not put a warning so everybody know. So we put a warning, then we'll go to functions real quick. So I don't mind, I'm looking for emoji. I like emojis. If you're chatting with me, I used to send emojis a lot. All right. So warning, let's call this warning. Sorry, let me lock my door. There's some noise coming. All right. Apologies, guys. Real apologies. All right. Warning. Today's not Saturday now. All right. Warning. Oh, today's Thursday, Friday. Warning. You must ensure to have a stop condition. You must ensure to have a stop condition. This is it. You must ensure to have a stop condition. If there's no stop condition, look inside here. Sorry. Is there anything that tries to stop this program? Nothing tries to stop it. So normally something like this should only be used in a real sense. So what I'll do is I will not say person name. I will show you what I mean. Is equals to Samuel. Guys, look at what happens here. I change person name to be Samuel. When you just do your use one equals to sign, that you're assigning something to something. So from the moment you started the program, person name was bounce. The while loop now check, is person name equals to bounce? Yes, then it printed this. It means after the first time that I printed it, I immediately changed person name to Samuel, meaning when the while loop wants to do the job again and it's checking what is inside person name, it will not see bounce there again. It's Samuel to now see there. But because Samuel is what is there, it's no longer bounce. The while loop will say, my job has ended. I only do my job if it is bounce. So when I run this, it will only do this once. It will only do this once. It will only do this once. Why? Because immediately I changed person to Samuel. So it only did this for that 1 second or that one chance when person name was bounced. That's when it did this. So that's the thing for a while. We must always have a stop condition. Always have a stop condition. So my own stop condition is that as long as person name is bounced, oh sorry, you must always have a stop. You must have a stop condition and an operation that allows the while loop to uh, to end or return false. Sorry. Must have something that makes the while loop to return false. So me, when I do these things across somewhere, it will surely make this guy to return false. So this guy that was starting it is the same guy that's ending it because it's the one that I made to end. Yes. I made him to become someone so that eventually it will end. How did I stop it from running? Very good. Oh, sorry, you didn't see me. See this button here, interrupt the kernel. Thank you very much. Interrupt the kernel. I'm so sorry. Interrupt the kernel. This guy, do you see him? It's been right in front of you. Press it. Now, most people, they use I, they'll be pressing I. It doesn't work all the time unless you press your escape. You have to press escape, then I, and tapping I multiple times. It's not, that works if your mouse have hang and your keyboard is still working. If your mouse have hang but your keyboard is still working, you press escape and you press I multiple times. It's going to interrupt. For me, my mouse was still working at that time, so I quickly dragged it to this place and I was pressing this interrupt multiple times. Pressing it once does not work. You have to spam it. You have to spam it like you're spamming your crush with your confession. You're trying to win her over. I'm pressing this. Please accept me, something like that. So let's go. Functions. 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 So that's loops. So as you can see, this is breaking ice so that you can do anything you thought was not possible before. Okay. Let's go. Functions. Guys, what are functions? You see this print statement, see this print statement. It's not you that put it there, right? You've been using it as a function. That's a built-in function. What if you want your own, you want to add your own? What if you want to add your own? What if you want to add your own? That's where creating your own functions come in. So this is called creating user defined functions. A function is just an operation. A function is, I didn't define a function. Yeah. A function is a reusable block of code. All right. A function is a reusable block of code. Yes, that's just it. And I'll explain what I mean by that. So guys, look at this. Look at this. If I want to let me get three people's name in this chat. I want to if I want to say um, good morning. Have I seen the morning? Oh, in the afternoon now. Sheesh. Good afternoon. Ikaba. Oh, sorry, Ukaba. As you see something, you see that I'm repeating myself, which is not nice. Good afternoon, Ukaba. Good afternoon, Chigozie. Those of you that are hiding, no problem. Hide your name well. They will born one child tomorrow, they'll give him that name. So your name did not hide. Rashid. What else? Siri. Let's leave Siri. Oh, who's Siri? Okay, let's do Siri. Yeah, an Apple fan. All right, we're done with this. Guys, take a look at this. When I run this now, you see how I'm printing good afternoon, Kaba, good afternoon, Chicoze, good afternoon, good afternoon, Rashid. What if I can store this information somewhere and the function just does it for me? I don't have to do it myself. Because now, see, I just printed good afternoon, all these people, right? Very good. Now, I said the function is a reusable block of code. What if I can save this thing so I can do it multiple times and I don't have to be writing myself all the time? Well, that's where I'll save it in a function. So I'll do like this. I'll use a def keyword to create a function. Whenever you want to create a function, you always use the def keyword. Always use def keyword. You always use the def keyword. And then you specify the name of function. Specify name of the function. Specify name of the function. So I'll call this function greet them. Specify name of the function. Put your brackets, shortcuts. Thank you. I'm not okay. All right. Put your colon and then indent the code. Guys, see all this code here, right? I'll just save it inside here. Come and see. Do you see? See how I save them, all of them? You see it? That's what your function does. The function says, what's that thing you want to do? Somebody has given me grammar, parentheses. Says no bracket. Bracket is for mathematics. Thank you very much. Parentheses. These are people that went to school. So put your parentheses, put your colon and indent the code. Look at this thing right here. When I run this, I have told Python, I know that you don't have any function called greet them. So create this one for me. It's called greet them. Put all these things inside there. Now, what's left for you to do is call the function. Guys, what's left to do is to call the function. When you want to code like this just creates the function. This only creates the function. So you're an architect. You're a master builder. You just built something. So in your mind, you have built something. It's up to you to now use that thing. So to use it, you just call it. Guys, what's the name of this thing? When I was creating this function, what did I call it? What did I call it? What did I call it? Greet them, right? All right, so let's do like this. I just say greet them. I just will make mistake. Call the function, ensure to add the parentheses. If you know how it is, Akami, Angela, Angel. And I said, Samson, do you think Samson will be in Samson? So I need something to let him color Wale. That's when he will answer. Well, the way same thing with this function, I must have these brackets, these parentheses in front of them. I mean, at the end of them. If not, I haven't called them yet. See, when I do like this, I haven't called them yet. I have only looked into them. When you do something like this, you're just looking into it. But if you want to do his work, you want to call him and say, Akman, come and wash this motor. Come and sweep this floor. You have to put this brackets in front of it. That's what there's a function that, oh, you're actually calling him. So when I run it now, the function comes, and you see those code that I put inside him, it will do those codes. That's it. So that's what the function is all about. It's just a reusable block of code. So it is this concept that we now use to create solutions that solve real problems. So right now, in this case, it's not solving any problem for you. But for me, I don't want to type the code that will greet all these people. So this is my own. In your own case, it could be something else, right? Then let's add the doc string, like you said. Now, what is a doc string? A doc string, as the name implies, is a documentation string. What is documentation? Documentation is a written piece of information for somebody to read about a product, like a manual. So let me show you. Look at this print statement. Do you know that most people don't know how to use this print statement? They don't know how to use the print statement. So they will try to go and look for the doc string of the print statement. So most people will go online. Let's go online. And someone's hand is up. You can write your question and I'll answer it. If I go online and I say documentation for print function. Now my screen is so tiny, don't mind me. My eyes is too sharp. Documentation for print function in Python. So let me see. I'm looking for a documentation, and let me say I come here. Now the thing is, this is what you can't even find it. Where is it? Where is it? Print. Thank God. Now see, this is everything that they wrote about the print statement to help you understand the print function rather, to help you understand how to use it. See it here. This is it. But the thing is, do you want to be going to your website to go and read it? Why can't you just stay inside there and read it? Why can't you just stay inside there and read it? Okay, so to read it, if you're on Jupyter Lab, press Shift Tab and this thing opens up. Shift Tab. I'm going to put the command here. Shift Tab. Press Shift Tab. So stay inside the function anywhere by the left, by the right, inside, outside, just press Shift Tab. And this thing comes, this is a doc string. This is something that they put here for you to read. So you don't have to go anywhere else to go and read it. But the fact that you are able to see these things is because somebody prepared this doc string that for you to read. So for my own function, people may not know how to use this greet them. They don't know how they should call it, whether they should say A is equals to 1, B is equals to Get. They don't know. So I'll create a string, a multi-line string, 1, 2, 3, enter, 1, 2, 3. In between this 1, 2, 3, I now write, I will say, this is how you greet people. If I do it like this, anybody that wants to know how to use this guy, they just have to type greet them, and then press Shift Tab, and then see they'll see that thing that I wrote. This is how you greet people. Who put it? This is how you greet people there? It was me. How did I put it? When I created the function, I added a multi-line string. A multi-line string is an information about how to use a function. So I'll just say this. So you're supposed to make it descriptive and explanatory. This function greets Ukaba, Chigozie, Vicky, Rash, and Siri. So I don't have time. Yeah, when I do this now, anyone that sees this knows that, oh, this function greets. So before they even run it, let's clear this cell out. Before they even run it, they'll just press Shift Tab and they say, oh, this function greets Ukaba. So if I don't want to greet these people, I should not run this function. But because they've read this information, right? They will not say, let me run it. Yes, this is what I want to do. So this is how a function works to start with. Then if you look at my function here, there's nothing inside these brackets. That's because a function uses inputs. But if you don't put inputs, no problem, it will still work. So it's up to you to now say, do you want to use inputs? So if I want to use input, I'll create a function. I'll call it SumDs. SumDs is going to take A and B and C. And it's going to print A plus B plus C. That's what it does. That's what this function does. But now if you look at this function, it doesn't have docstring. So I'm supposed to put the docstring that's supposed to say 1, 2, 3, 1, 2, 3. That's how you make a multi-line string. A multi-line string, a dot string is just a multi-line string, meaning a string that goes more than one line. That's what it means. So I'm going to say this guy, sorry, pardon me. So say this guy, let's just say about this guy. This guy has A with B and C. Now, if anybody wants to use it, just say sum these. See the sum these, you just press shift tab and you say, oh, this guy has A with B and C. And then I'll just say 10 plus 10 plus 10. You guys know the answer. 30. Do you see it? That's a function. So it means that whenever I want to add 10 plus 10 plus 10, I don't need to do print 10 plus 10 plus 10. I'll just say sum these and it does it for me. So it means that it is this guy I am reusing. Do you understand? This is the guy I am reusing. So instead of me having to say print A plus B plus C, I will just say print and sum these 10 plus 10 plus 10 plus 10. Yeah. All right. Now we're supposed to go into your code challenge, but I think with what I've shown to you guys, right, you guys can make anything possible. Do you have questions for me before the meeting ends? Yeah, you can tell that NEPA has carried my lights, right? Let me off my camera. But I'm still here. So guys, to know this, just put in the work, learn, practice. So now we can make arrangements for that. Bounce. We can make arrangements for that. That should be able to help you guys on the meetings. We can make arrangements for that. Then big O notation. Big O notation. Yeah, that's a fancy concept for how efficient a program is. So look at my solution right here. It's good for summing three numbers. So if someone wants to calculate the efficiency of this command, does the speed increase? Is it powerful if it's just three numbers? If it's just three numbers, it works. Okay, if it's four numbers, does it still work? Good. What if it's a million numbers? Will it work? What if it's 10 million numbers? Will it work? That's what big O notation tries to do. So it gives every algorithm a label based on how efficient it is. It gives every algorithm a label. So sometimes it may not be a function. It's actually anything you write should have anything you write is efficiency can be measured with big O notations. And then there are different scales that you use. There are different scales that you use. So I think we'll get into that on our maybe next time we meet, we'll get into that. Yeah, we'll get into that. Okay, Rashid's hand is raised up. Yeah, I think he's trying to let us know. Yeah, time is gone.
Hi guys. Sorry. It's almost time. It's almost time. Um, yes, we're supposed to say another program is supposed to hold by 12 p.m. So I was only given a time frame of 10 a.m. to 12 p.m. But we're going to have this session next week, Friday, same time. It's a recurring session. Now, someone asked if we can have the session twice a week. Uh, there's a possibility that we can have it twice a week, but I also need to check on Samuel's availability as I need to check on his availability. That is one. Also, we don't want the session to be too lengthy and compound you with too many information, right? So for now, and I'm still trying to settle with Cohort 8, data analytics, Cohort 9, data analytics, and all that. So once we get a stable foundation and we are able to draft out the program plan for everyone, right? No. Nobody's paying for anything. It is free. We are giving back the same way we got it. That is also the same way we are giving back. Please, nobody's paying for any session. If anybody's asking you to pay, please reach out to me. Nobody's paying for anything. The worst case scenario is I can ask Samuel if he wants to be added to your general platform, whereby anytime you have any question, you can tag him on it. Depending on his availability, we attend to them. There's also Caleb on your platform, but most of you do not know that these guys are already there. So please, no payment of anything. It's just a service, right? Then let's just keep having it every Friday, 10 to 12. If there is going to be twice a week session, I would inform you on the group chat. I'm going to inform you guys on the group chat. So, like I said before, tell a friend to tell a friend to tell a friend. It is um a session, right? It's going to always be around this time. Always going to be around this time. I'm sorry I had to cut the session. Yes, they did not introduce themselves. I'm going to drag them out to this week. Before the end of the week, I'll drag them out. So tell a friend to tell a friend, right? I know you guys gained something today. You were able to lay a foundation for what it is that you learned. Hey, don't go yet, oh, Ola. Don't go yet. You fill the form. Maybe you should not leave yet. There is form. On that group chat, I said something. I said, allow us to help you. Then you can also help us. Please kindly fill the. I sent a link just now. Please fill the form. It's just a feedback form on how this session. Just copy it and paste it on your browser. Okay, it's not clickable. Don't worry, I'll make it clickable now. Yes. So just tell a friend to tell a friend. Anytime you're having issues, right? Just reach out to. You can reach out to me in my DM. Don't worry, you'll get the recordings today. It's going to take a while to process. Then we'll get the recordings. So tell your friends, tell everybody, go to the group chat and say, oh, I gained something today. Oh, you did not attend, you missed. Oh, I met Samuel today. He explained very well. Oh, you guys missed. Oh, I met Ross today. He's a vibe. Oh, he's not a vibe. Is this, is that. Just tell people how it was today and let them understand that it's always going to be there. We have a lot of support for you guys. We want to push as many data scientists as there are outside there today. I met Bounce also. We want to push as many data scientists as there are outside, not just data scientists or data analysts, but quality data analysts and data scientists who can always ace um projects or interview sessions or whatsoever. So yes, thank you very much, guys, for attending today's session. Um, this is Samuel, like I said before. I'm going to add him to your group if he allows. So you guys should beg him for him to allow me to add him to your platform. Then we'll just try and see how we can catch up on your various modules. I think you guys are supposed to have a code challenge for this week. So we'll just keep seeing what we can come up with. And also, if there's going to be a twice a week session, if there's going to be a twice a week session, it might be Wednesday, Friday, or Monday, Friday. It depends on Samuel and also your availability, because I know that most of you work. And that one will be on Google Meet, not on Zoom, because of the amount of programs that ALX has and the availability of um, Zoom links. So we might need to switch at some point to Google Meet. Then for the Friday sessions might be Zoom sessions. So once I draft everything out, I should have a proper plan. Okay. So I should have a proper plan for you guys. Latest on Monday, everything should have been drafted properly. So Samuel, do you want to be added to their platform, or should we keep it the way we are keeping it? Hello, Samuel.
You can add me. You can add me. Yeah.
Okay.
Mm.
So you can see now. So it's going to be added to the group chat today. So in case you're having any issues, code bugs, whatsoever, please do not go to his DM. Very important. Do not go and flood his DM. Drop it on the group chat so that other people can learn. Okay. If you have any specific issues, enter my own DM. If you have any specific issues, enter my DM. If I hear that Bounce entered Samuel's DM, we're going to have issues. Okay. So you guys should have fun. Have as much fun and have a wonderful, wonderful holiday and weekend. So keep studying. There's no amount of study. Okay. For me, how I started with my own learning was I look at the modules, right? And sorry, we're supposed to play a game today, but because of time, I promise next week we're going to have a game and there might be prizes, probability. So how I started is I go through the modules. If I do not understand iteration, while loop, for loop, I use my AI to understand better. I tell it to teach me like a layman, teach me like a dummy, teach me like you're teaching a 5 year old, right? And give me illustrations I can easily understand. That is using AI to understand better. Not that you go and carry your code and give it to AI and tell it to solve it for you. Yeah, because at that point you will not be able to understand what you are doing. Sometimes if it's in the example, I will copy the code. Oh, explain to me line by line what each code is doing. What are they actually doing in this particular block? There's going to tell me, oh, this for loop here is doing this while loop here is doing this. Oh, for this or this, for this, for that, blah blah blah. It's going to break it down to you one after the other and explain it properly to you. This is how to make use of AI tools, right? Not that you go and carry all the whole assignment and drop it there and it will solve it for you. No, that's not the way to go. It doesn't aid your learning. Okay. So have a wonderful, wonderful afternoon, guys, and bye for now. Okay, why am I the only one managing multiple cohorts? Okay, don't worry. So Anozie is around. Anozie is just recently joined the team. So Anozie is going to be your main data community experience learner. Me, I will be in the background. Okay. So at some point in time, I will shift the responsibility to Anozie. Then I will move away step by step, slowly. But that does not mean I'm not still going to assist. I'm going to assist in every way I can. The sessions are still going to hold. The Like I said before, for those that came early, there's a colleague of mine, Rhoda. She'll be reaching out to you individually to find out where you're having issues, where you're lagging behind, and all that. There are a lot of support for you. Okay, in as much as we are stepping out, you guys are always still going to get the best support that you can get. Okay, I still need to go and manage data analytics, guys, and Quart 9 and others. So yes, have a wonderful afternoon. So thank you, Samuel, for attending to this session. Bye. Any question, come to the group, come to my DM. But for today's session, it's a wrap. Have a wonderful day, guys. Bye.